Okay, this is going to be a brief review of 3.1, 3.2, some stuff from 3.3. So, the parent of the quadratic function, this was graphed on a lot of the graphs that were handed out or that were in the notes. F of x equals x squared. Its graph is the parabola shown. The axis of symmetry is x equals 0. The vertex is 0, 0. So this is the parent function of all quadratic functions. We start at 0, 0, and the axis of symmetry is also at x equals 0. The general equation for a quadratic function, and if you don't know this by now, that's a problem. F of x equals ax squared plus bx plus c. Okay, try this again. Alright, so graphing each function. So here we have the parent function on the graph already. The parent function can help us graph functions. There are a couple different ways that we can graph. So we're going to go ahead and start with the first one, x squared plus 3. The vertex for this function is 0, 3. All that we've really done is we've taken the parent function and we've added 3 to it and that is the y coordinate. So that means that we've moved up 3 spaces. Okay, so we're going to take each of our points and move them up 3 spaces. This is one way that we can graph. Okay, so I'm going to take my vertex here. My vertex should be at 0, 3, so I've moved the vertex up 3 spaces and plot my point. Oops. Okay, take my other one here, second one, moved it up 3 spaces, plot my point. And then I'm just doing the same thing for each of these. I'm moving all of the points up 3 spaces and plotting. Okay, and after I have that, I can go ahead and draw my line in. So, here we go. Not perfect, but good enough. Okay. Second one, h of x equals x plus 1 squared. So what we did here, we have a vertex of -1, 0. So all we did to the original parent function was moved it 1 space to the left. So we're going to take all the points that are on the parent function, these 5 points, move them 1 space to the left. Okay, and then I would go ahead and, ooh, too big. Make that a little smaller. Go ahead and draw my, ooh, a little bit off there, but that's okay. Draw my line in. Alright, and for the third one, we're going to change this up a little bit. I am going to use a table. So, for the table, I need to put my vertex in the table, obviously. My vertex for this one is -1, 4. We do the opposite of the inside, we keep the same number on the outside. And I'm going to put the vertex in the middle of my table. And then I'm going to choose 2 points below, 2 points above my vertex. So I choose the x coordinates that are right around it. And we can take these x coordinates and plug them into the function to figure out what y is. So if I take -3 and I plug it in, -3 plus 1 is -2, squared is +4, times -2 is -8, plus 4 is -4. Okay, and then I'm going to do the same thing for my other ones. -2, plug in, so -2 plus 1 is -1, squared is +1, times -2 is -2, plus 4 is +2. And after I fill in the rest of my table, you can see that the y coordinates end up being the same on both sides, which is what should happen. Remember, the vertex cuts the parabola in half, and all the points that are on one side are reflected to the other side. So your y coordinates should be the same like this. And then I would just go ahead and graph it. So I am going to graph this one in black, so we have another color. Alright, so I'm going to graph the vertex at -1, 4. And then I'm going to graph the rest of my points here. -3, -4, -2, +2, 0, +2, 1, -4. Oh. Let's try that again. There we go. Could be a little more around here. And make sure your lines are extending all the way to the end of the graph. Okay, so we're given the function y equals -2, x minus 1 squared plus 3. We want to determine the axis of symmetry, the vertex, whether the function is stretched, compressed, or neither, whether the function has a maximum or minimum, and where that maximum or minimum is, and the domain range of the function. So starting with the first one, the axis of symmetry. Axis of symmetry is just the x-coordinate of the vertex. It's that line that runs through the vertex. So axis of symmetry in this case, the x-coordinate of the vertex is opposite of what's in the parentheses here. It's going to be a +1, so my axis of symmetry is +1. The vertex will be 1, 3, and that comes from these two numbers, opposite of what's inside and then the same number that's on the outside. Whether it's been stretched, compressed, or neither, that is given to us by whatever number's in front of the parentheses. So not paying attention to the negative means something else. That tells us whether it's been reflected or not. Just the number. Is the number greater than 1 or is it less than 1? If it's less than 1, like a fraction and a decimal, something like that, that's when it has been compressed. Okay? And then if the number is greater than 1, so in this case we have a 2, then that is when it has been compressed. So for this one, it has been compressed. And then when it's neither, that's if it's equal to 1. There isn't a number in front of it, at least not a number that's actually written. If it's just a 1, it's neither. This function has shifted up or down, left or right. So we look at our vertex. So the vertex, we've gone to the point 1, 3. So that means we went to the right on the x-axis and we went up 3 spaces on the y-axis. So this is going to be up and to the right. This function has a maximum or minimum. That's going to be told by whatever number's in front of the parentheses. If you guys remember from class, remember Max is sad, he's negative. The number in front of the parentheses is negative. We have something that looks like a frowny face, and it has a maximum value. Okay, max is negative. And then minimum is positive. So for this one, it is a maximum because it has a -2 in front of the parentheses. And your maximum or minimum will be at wherever the y coordinate is. It's going to be at +3. The domain. Domain is always going to be the same thing, all real numbers, which is what this symbol means. And I'll probably write it out so that way we have it. All real numbers. For all quadratic functions, unless there's some kind of specific limit on the domain. They're going off in both directions, left and right, forever and ever and ever. They cover all of the x values. So it is all real numbers. The range, this is where our y values are. If we have a maximum, that means all the y values are going to be below a certain point. So if I have a maximum, all my y values are below that maximum. So they're all less than or equal to that number. When I have a minimum, that's when it looks like a happy face. All my y values are above that point. So for this one, it is a maximum, so it's going to be less than or equal to. And then again, just using the y coordinate. It's less than or equal to +3. Okay, graphing in standard form. So we have y equals x squared plus 2x plus 1. First thing I'm going to do is fill in this box on the bottom here. So my axis of symmetry for this. Remember our equation, -b over 2a. So in this case, a is equal to 1, b is equal to 2, and c is equal to 1. And I'm going to plug those in. So -2 over 2 times 1. That's -2 over 2. So this gives us the axis of symmetry and also the x-coordinate of the vertex. They're the same thing. So the axis of symmetry is -1. Or, I'm sorry, x equals -1. There we go. Axis of symmetry is the equation of a line. The vertex is going to be -1, comma, and then I have to figure out what the y value is. I found the x coordinate, so to figure out the y, I take the x and plug it into the original function. X squared plus 2x plus 1. So x squared is going to be -1 squared plus 2 times -1 plus 1. Okay, so we end up with 1 minus 2 plus 1, which gives us 0. So our vertex is at -1, 0. Is it a maximum or min? So we look at what's in front of the x squared. So again, if it's negative, that means that it has a maximum. Since this is positive, it's a positive one, it's going to be a minimum. And the minimum, remember, is at the y coordinate of the vertex, so minimum's at 0. And then finally the y-intercept. If you guys remember from the notes, it's 0, c. So for this one, it's going to be 0, +1. Okay, so we can actually go ahead and graph our vertex at -1, 0. And we have the y-intercept. So what I'm going to do here is I'm actually going to draw in our axis of symmetry so we can see where the middle of our function is. Our y-intercept is at 0, 1. And remember, we can take any points and reflect them over the axis of symmetry because parabolas are symmetrical. So we have 2 points. They're a little bit close together though, so maybe add in one more point just to make sure that we have a nice full parabola. So I am going to plug in +1. You can plug in any x value that you want. I'm choosing +1 because it's still close to my vertex. It's right here. So I'm going to figure out where, if I plug +1 in, where do I plot my point? I need the y value. So when I plug +1 in, I get 1 plus 2 plus 1. So my y value is 4, which means that there's another point at 1, 4. And this is just going to help me fill out the parabola. So I go to 1, 4, and then I'm taking that point and reflecting it over the axis of symmetry. Now I have a better idea of what my parabola actually looks like, and I'm going to go ahead and draw it in. Okay, so now we are going to be factoring completely. For the first equation, there are several things that we can factor out here. So we first look at the coefficients. We've got 12, 9, and 15. The largest number that we can factor out of 12, 9, and 15 is going to be 3. If you're not sure how to find that, list the 3 coefficients and then list their factors. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. The factors of 9 are 1 and 9, 3 and 3. The factors of 15 are 1 and 15, 3 and 5. So you can see that the 3 is the number they all have in common, the greatest number they all have in common. So I know I'm going to be factoring out a 3. And then next I look at the w's. I have w to the 3rd power, w, and w squared. So it looks like I'm only going to be able to factor out a single w, just to the 1st power. And then the t's, we have a t squared, and a t to the 3rd power. So it looks like I will be able to factor out a t squared. So to factor something out, what we're really doing is dividing by that factor. We're dividing each of these by 3w squared. So 12 divided by 3 is 4. W to the 3rd power divided by w. Remember we subtract the exponents, so it's going to be w squared. And t squared divided by t squared is just 1, and we don't need to write the 1. Minus 9 divided by 3 is 3. my w's are going to end up canceling here. They cancel out to 1, and so do the t squareds. So we do not have to write that. If it's just a 1, 3, if I wrote the 1 here, 3 times 1 is still just a 3, okay? Or a minus 3 times 1, really. So we don't have to write times 1. We just cancel these out instead. And then the last one, 15 divided by 3 is 5. W squared divided by W is W. And t to the third divided by t squared is t. So we write what we have left over in the parentheses. And typically, when we write these, the exponents will be written in descending order. So that means that I would switch this around to plus 5wt minus 3. But honestly, that part really doesn't matter. If this is what you had, it wouldn't be incorrect. This is just the w's are written in descending order. Okay. For the next two, we're just factoring. This is what we did in class. So I'm looking for the two numbers that are going to multiply to give me negative 12 and add to give me a positive 4. So I need to list the factors of negative 12. And there are a lot of them. So negative 1 and 12, those are not going to add to give me a positive 4. 1 and negative 12 will also not add to give me a positive 4. Okay, 2 and negative 6, that will add to give me a negative 4, so I'm getting closer. Negative 2 and positive 6, those are the ones that I'm looking for. So I split the n squared up into n, and then I put my factors in. N minus 2 and n plus 6. For the second one, we're actually going to be able to factor out a number first. If we can, we'll factor out the number that's in front of x squared. So we're taking a 2 out here. And when I take that number out, that means I'm dividing by it. So 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. And 4 divided by 2 is 2. And then I would go ahead and factor what's in the parentheses now. I can take this and factor it further. So I want the two numbers that multiply to give me 2 and add to give me a positive 3. So my factors of 2 are going to be 1 and 2, negative 1 and negative 2. So obviously it's going to be the positive 1 and positive 2. And that's it. Okay, so now we're going to try another example. Oops. 3x squared plus 10x plus 7. So what we're doing here, since we have a number in front of the x squared, we cannot factor out the 3. We're going to have to do factoring by grouping. So factoring by grouping starts with multiplying the coefficient in front of the x squared times the constant. And then I list those factors. And it looks like the few factors that are going to add to give me the middle term, I'm looking at the factors of 21 that add to give me 10, are 3 and 7. So what we do next is rewrite the 10x as a 3x plus 7x. Okay, all I did was I rewrote 10x as 3x plus 7x. It doesn't change the expression in any way. Now I am going to group my first two terms, my second two terms. And then next we are dividing out the greatest common factor. So I'm dividing out a 3x. And when I do that, I have x left over plus 1. For the second one, my greatest common factor is 7. So I will have an x plus 1. And this is what we should end up with, where we have x plus 1, x plus 1. Whatever's in parentheses should be the same. So now we are regrouping here. The x plus 1 then, since it's something that these two have in common, it is its own term that I am going to be dividing out here. And whatever's left over is what goes in my second set of parentheses, 3x plus 7. And that's it. Okay, and then this last one is the difference of squares. So for difference of squares, this is something we did in the station rotation, or rotation stations. We have to have a perfect square for both terms, and we have to have a minus sign. It's the difference of two squares. So the difference of two squares is fairly easy. For difference of squares, we set it up as the square root of the first term is what goes here. The square root of the second term is what goes in our, let me write this here. Okay, the square root of the first term will be the first term in each of our parentheses. The square root of the second term is going to be the second term in each of our parentheses. And if you guys will remember, one is plus, one is minus. So we want the square root of 16x squared. So the square root of 16 is 4, the square root of x squared is x. So 4x is our first term in our parentheses. And then we want the square root of 25, which is 5. So the second term is going to be 5. And this is all we have to do. We take the square root of the first term, goes here, square root of the second term, one's plus, one's minus. That's how we do difference of squares, factoring a difference of squares.